Problem 47, quantum mechanics. The question is, the wave function of a state of the hydrogen atom is given by psi equal to psi 200 plus 2 psi 211 plus 3 psi 210 plus root 2 psi 21 minus 1, where psi NLM is the normalized eigenfunction of the state with quantum numbers NLM in the usual notation. The expectation value of Lz in the state psi is. Here we have to find out the expectation value of the operator Lz in the given state psi. We know that if psi is normalized, the expectation value of Lz is the inner product of psi with Lz psi. So it is essential to check whether the given wave function psi is normalized or not. First, let us check whether the given wave function psi is normalized or not. First, let us write the given wave function psi. This is equal to psi 200 plus 2 times psi 211 plus 3 times psi 210 plus root 2 times psi 21 minus 1. Now let us take the inner product of psi with itself. That is nothing but the inner product of psi 200 with itself plus 4 times the inner product of psi 211 with itself plus 9 times the inner product of psi 210 with itself plus 2 times the inner product of psi 21 minus 1 with itself, and that is equal to 1 plus 4 plus 9 plus 2. That is equal to 16. That is, the given wave function is not normalized. So we have to introduce a normalization constant n is given by 1 by root of the inner product of psi with psi. Here n is equal to 1 by root 16. When you multiply the given wave function with this n, the wave function become normalized. So actually n times psi that represent the normalized wave function, where n is equal to 1 by root 16. Now let us write the normalized wave function psi. This is equal to 1 by root 16 psi 200 plus 2 by root 16 psi 211 plus 3 by root 16 psi 210 plus root of 2 by root 16 psi 21 minus 1. This is the normalized wave function. Now let us find out what is Lz psi. What happens when Lz operates on this normalized wave function psi. Now Lz acting on psi, that is equal to 1 by root 16 Lz psi 200 plus 2 by root 16 Lz psi 211 plus 3 by root 16 Lz psi 210 plus root 2 by root 16 Lz psi 21 minus 1. We know that when Lz operates on the state Lm, you will get mh bar Lm. Hence, Lz psi becomes 1 by root 16 0 h bar psi 200 plus 2 by root 16 1 h bar psi 211 plus 3 by root 16 0 h bar psi 210 plus root 2 by root 16 minus h bar psi 21 minus 1. Therefore, Lz psi is 2 h bar by root 16 psi 211 minus root 2 h bar by root 16 psi 21 minus 1. This is Lz psi. Now we have to find out what is the expectation value of Lz in the state psi. For that purpose, we have to take the inner product of the normalized wave function with Lz psi, that is psi Lz psi. This is equal to 1 by root 16 psi 200 plus 2 by root 16 psi 211 plus 3 by root 16 psi 210 plus root 2 by root 16 psi 21 minus 1. Take the inner product of this with Lz psi. What is Lz psi? That is 2 h bar by root 16 psi 211 minus root 2 h bar by root 16 psi 21 minus 1. So when you take the inner product of the normalized wave function psi with the Lz psi, we will get the expectation value of Lz in the state psi. Now Lz, the expectation value of Lz is nothing but 4 h bar by 16, the inner product of psi 211 with itself, minus 2 h bar by 16, the inner product of psi 21 minus 1 with itself. That is 4 h bar by 16 minus 2 h bar by 16, that is equal to h bar by 8. That is the expectation value of Lz in the given state psi is h bar by 8. Therefore, option D is the right option.